Hello students and seekers of truth. In this video we will study joint variation. So this is defined as when one product varies directly with the product of two other or more quantities. Okay, so it's like you have, let's talk variables. Let's say the variables here are x, y, z. Okay? And when you say y times x or x times y is always related to z times some constant, and I'm going to call this constant k. Okay, so this is going to be an actual number, and it's always going to be the same one regardless of how x and y and z changes. So that was a little bit cryptic. That was a little bit difficult to understand perhaps because there's a lot of technical words meshed together. Let's try to unpack it with an example. So the variable z varies jointly with x and y. So we can describe it this way, actually using the formula I have here. X times y is equal to k times z. Okay. When z is equal to 60, when x is -1 and y is 5. So this is how maybe we can organize things: x, y, z. So we have a table of 3 values now. When z is 60, x is -4 and y is 5. Okay. Find z when x is 7 and y is 2, and so z is the question mark here. Okay. So our goal in these problems is to figure out what's the constant of variation. This is the very important number here, k. So we're going to use this first row to figure that out. We know that when x is equal to -4 and y is equal to 5, and then z is equal to 60. Okay. So now we're going to solve for k. So this is -20 is equal to 60k. So divide both sides by 60, and we get that -1/3 is equal to k. And now what we can do is effectively update the equation. So we now know the new formula, the better one, is x times y is equal to -1/3, that's k, times z. So now to answer our question, we use x and y to substitute, or 7 and 2 to substitute for x and y. So when x is equal to 7, we know that y is equal to 2. K, once we figure that out, that never changes. It's always going to be -1/3. And that's equal to z. Okay. So this is 14 equals -1/3 z. Multiply both sides by -3, and we get -42 is equal to z. Okay. So there you go, the definition of joint variation and an example. Let's march onwards, and let's look at some examples here where we don't really get to use numbers. Okay, z varies jointly with x and the square root of y. So the square root of y here is like one quantity on its own. So we know that z times some constant is going to be equal to x times the square root of y. So jointly means that there are two variables multiplied together to get the third, and they have a difference of some constant, k. All right, let's try p varies inversely with the cube of q. That's a fun mathematical tongue twister, cube of q. Okay, so remember what inversely means, right? So if you divide a constant by one of the variables, you get the other. So we can say that p is equal to some constant, k, divided by the cube of q. So here's q and cubed of q. Okay, so we're seeing inverse relations here, and joint relations here, not of just a raw variable, but an operation that's done to that variable. And that's perfectly fine. One last one. M varies directly with the square root of n and inversely with p. Okay. So this is interesting. So we can say that m varies, let's take the first part, varies directly with the square root of n. Okay. So m varies directly. That means m is equal to k times the square root of n. Okay? But inversely with p. So that means if you were to increase m, then p would decrease, or vice versa. So you get an equation that looks something like that. Okay? And so here, I know that this is a little bit weird mathematics. Suddenly we have all this equation with with many variables. Usually you're used to solving equations with one variable, or a system with two. But what we're working with here is just describing how these things are related. And when you actually go to solve these problems, you will have more numbers to work with than you did before. So for example, up here, we had x, y, and z, but when we went to solve the problem, we had a bunch of numbers that we could use here to solve it. Okay, so all right, so let's end this lesson here on just a simple statement that you're going to fill in, checking to see if data varies directly. Okay, so how do you know if data is going to vary directly or not? So I will leave you to answer this question on your own. When we return in class, I'll be happy to check your answers for you. What is really of the utmost important here is that you can identify data that varies directly. Even if you can't articulate it yet, I will help you with that. So here's an example for you to think about. Here's one that you may be familiar with. PV equals nRT. Which one of these variables varies directly with the other, and which one of these variables vary inversely with each other? Okay. So I'll leave you to kind of think through this a little bit, so you can think of it directly. If you increase one of these, what's the other one's going to do? Okay, so you have 5 variables here. And I think maybe you think back a little bit, you see why this equation is useful. Okay, so try to articulate for yourself, for your own understanding, what is it that makes data vary directly? And we already talked about what makes data vary inversely and jointly. Well, keep working hard. As always, thank you for taking your time to watch this and doing it earnestly. And whenever you need help, just ask, and have a wonderful day.